10. Which of the following nuclei lie within the band of stability? And we have magnesium-24. Okay, so is magnesium going to lie within the band of stability? Meaning, is it a stable isotope? If you are in the band of stability, you are a stable isotope. And if you are within the band of stability, you are one of these purple or blue ticks on this graph. If you're lying in the green region, that is unstable area, and you would not be within the band of stability. So there's a lot of unstableness out in this world, way more than there is stableness. But let's see. Let's take this and write it into nuclide notation, where magnesium is Mg, and maybe I'll change that. That's good enough for me. And remember, if they're in this notation where they have magnesium-24, carbon-14, oxygen-16, that number is always referencing the atomic mass. Because the atomic mass for an element can change. In this case, the 24 represents the total number of protons and the total number of neutrons. A mass always has both of them. So in our case, we have a total of 24 protons and neutrons. But if we want to find out what the band of stability is, or if this is in the band of stability, if it's a stable isotope, we need to find out how many of this 24 is protons and how many is neutrons. Now, in the nuclide notation, you do have two numbers, right? You have a number on the top and you have a number on the bottom. Generally, the top number is going to be the atomic mass. So the bigger number out of the two. Now, what is the smaller number? Well, the smaller number is the atomic number. And every element has its own unique atomic number. That's the number of protons. So, how do we find that out? Well, we got to whip out our periodic table. I got mine in front of me. Do you have yours in front of you? We got to find that special number proton atomic number for magnesium. And I see that the whole number here is a 12. So, you got 12 protons. And how many neutrons? Well, if the atomic mass is protons plus neutrons, and the atomic number is protons, what would we have to do to these two numbers? Yeah, you're right. We just subtract them. 24 minus 12 is a big fat 12. So I know that I have 12 neutrons. Now, the one thing to do is to find if you have a magic number. Chances are if you have either a proton or a neutron value that is a magic number, 9 times out of 10, it will be stable. These magic number of protons or neutrons, it kind of like is the same thing as filling out an electron shell, where if you have these, it's basically your nucleus is quote-unquote filled, and it's happy, it's stable. But I don't see 12 on my magic numbers. So that means I got to go to my actual graph. Now, as you're low on the totem pole, right, you'll notice that the band of stability aligns with this black line. And as you go higher and higher with your number of protons, right, you stray away from this black line. Now, the black line represents a 1-to-1 ratio, where if you have X amount of number of protons, that means that you should have the same number for your neutrons. That is so true for your bottom amounts, but as you stray away, those 1-to-1 ratios are not going to be stable anymore, and the number of protons versus the number of neutrons is going to be skewed, where chances are you will have a lower number of protons than neutrons to be stable. But, I mean, we're talking about 12 and 12. That's a 1-to-1 ratio, right? Now, is 12 a low number or low enough number for that 1-to-1 ratio? And it is indeed, because here's the 10. There it is, right? 10 and 10. And then that line right here is the 12 and 12. And maybe I'll 12 and 12. Let me just move that over a little bit. There we go. And we'll maybe just put that there. Here's 12 and 12. This might be a little bit, small on your screen, but I believe now YouTube you can zoom in. So if you want to, you could zoom in, or you could pull up, band of stability graph on your laptop or whatever just to see it. But it does reach a blue line, which is in the band of stability. So yes, this is a stable isotope. And that is the end of that. So this one, we're using the 1-to-1 rule to make it stable. And that's it. I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, and I look forward to helping you in more questions. We got a new school year coming up ahead, so we got tons more goodies coming your way. But yeah, we also have memberships on the channel if you want to check that out. Thank you so much for all your support thus far in this journey. And yeah, I'll talk to you soon. Bye-bye.